But we talked about a lot of things with functions. We're going to finish with inverse functions. You probably talked about them a little bit before in previous classes, but we're going to kind of add the exponential and logarithmic functions that we've done in here. We're going to kind of review. So first of all, let's talk about the definition of a function. Okay, cell phones up, earbuds out. Look at the gray paper that I've got on your desk. Okay, the definition of a function is that each element of the domain, okay, aka all your x's, okay, domain is x's, is paired with only one element of the range. Okay, so that means for every x, there is only one y. Another way of putting that is the vertical line test. Y'all done the vertical line test before. Okay, if you take a vertical line and you pass it across your graph, you can only touch the function or the graph in one place at a time. If an x value has more than one y value, that's when it's going to fail that vertical line test. So that's a function. An inverse function switches the domain and range, or switches the x's and y's of a particular function. So there's our notation for an inverse function. It looks like a -1 exponent. It's not an exponent. That's just your inverse function notation. Okay. You read this right here, f inverse of x. Okay, just like you would read f of x, it's f inverse of x. Okay. So let's look at two examples here. Let's look at f of x equals the absolute value of x. So over here on the left, this is what we call a function map. Okay, this is a mapping. Over here on the left are the x values. Over here on the right are the y values. So when we plug -3 into the function, absolute value, then the answer is +3. When we plug in -2 into the absolute value, we get +2. So they draw an arrow from the x value to the y value that matches it. Okay, according to the function. So, when you see only one line coming from all your x values, that means it's a function, okay, because there are not multiple y values coming from a single x value, okay? So, the absolute value of x is a function. Now, the inverse switches the x's and y's. Okay, so for the inverse, we don't know what the inverse of the absolute value is. Okay, but I'm going to write this in blue, f inverse of x. That means the right side is going to be our x values. The left side is going to be our y values. Okay, the inverse is not a function because if these are now our x's, one has two lines, two arrows coming from it. It has two y values. Okay, so its inverse, f inverse of x, whatever that looks like, is not a function. It's a relation. Okay, if something is not a function, it's a relation. There's still a relationship there. It's just not a function. Okay, it's not a function. So let's look at the other example. G of x equals x plus 3. Okay, when we plug in 0, 0 plus 3 is 3. When we plug in 1, 1 plus 3 is 4. When we plug in 2, 2 plus 3 is 5. Okay, so this function, okay, g of x is a function. Is its inverse a function? If we flip these around, is it a function? Yeah. Okay, if the right side is now our x values and the left side is now our y values, we still only have one value matching to one value. So this is also a function. Its inverse is also a function. If a function and its inverse are both functions, we call that 1 to 1. We call that 1 to 1. If a function and its inverse are both functions, then we call that 1 to 1. And it kind of makes sense. Every x has only one y. Every y has only one x. 1 to 1. Okay? So that's just some terminology that we need to be familiar with. Now, let's look at actually finding an inverse function because that's more likely what they're going to ask you to do. So to find the inverse of a function, we've got some steps. We're going to switch x and y in the equation. We're going to solve for y. Thank you very much. Just grab that seat right over there. Okay, solve the equation for y. And then in the very end, once we get y by itself, then we're going to replace it with that inverse notation. Okay, so let's start with a very simple function right here. Let's say that our function is g of x is equal to 3x. Okay, g of x is equal to 3x. So g of x is just a fancy way of saying y, right? So our first step is to switch x and y. So that means we're going to replace g of x, which is another way of saying y. We're going to replace that with an x, and we're going to replace the x with a y. And then we're trying to solve for y. We're trying to get y by itself. So how do we get y by itself right here? Divide by 3. Divide both sides by 3. So we've got x over 3 is equal to y. We're trying to find the inverse, so we need to replace it with the inverse notation. And I like that to be on the left, so I'm just going to flip this whole equation around. G inverse of x is equal to x over 3. G inverse of x is equal to x over 3. So 3x and x over 3 are inverses of each other. Okay, let's look at one that's got a little bit more. Okay, h of x is equal to 3x plus 5. Okay, same thing. We replace the h of x with just x. We replace the x with y. And we're solving for y. So we're going to start by subtracting 5 from both sides, because that's going to get one step to get y by itself. So we have x minus 5 is equal to 3y. And then just like before, we're going to divide both sides by 3. So we have x minus 5 over 3 is equal to y. We need to replace that y with our inverse notation. So h inverse of x is equal to x minus 5 over 3. You may see it, they may break this up and write that as 1/3 x minus 5/3. Okay, they're just putting each part over the denominator. They are equal to each other. Okay, I'm good with either one. You don't have to split it up, but I just wanted to point that out in case a multiple choice answer choice does split it up. Okay, let's look at C. Okay, similar to B, very similar to B. What do we need to do first? Switch the x and y. So what's our first step in getting y by itself? Add 7. Okay, so it's gone on the right side. X plus 7 is equal to 3y. Same step again. We're dividing by 3. So x plus 7 over 3 is equal to y. Replace it with that inverse notation. J inverse of x is equal to x plus 7 over 3. I'm not going to split that one up. Okay, let's do one more function here. K of x is equal to 3/5 x plus 4. So x is equal to 3 over 5y plus 4. What do we do first? Subtract 4. Dakota sit up. X minus 4 is equal to 3 over 5y. Okay, now, what do we need to do now to get y by itself? Okay, now be careful. We're not going to multiply by 3/5. We're going to multiply by 5 over 3. Okay, we multiply by the reciprocal. Because look at what's going to happen. We got a 5 in the top, 5 in the bottom, 3 in the top, 3 in the bottom. They cancel out. Okay, so we multiply both sides by 5 over 3. So we've got 5 over 3 times x minus 4 is equal to our y. Replace it with the inverse notation, and they're probably going to distribute that 5/3. So we have 5/3 x minus 20 over 3. Okay, now, the original functions, all 4 of these original functions, what type of functions were they? What do we call them? Linear, okay? They're all linear functions. How about those inverse functions? What type of functions were they? Linear, okay? They were all linear, okay? mx plus b, okay? C doesn't look like it's mx plus b, but if we split it up like we split up b, it's mx plus b, okay? Linear functions have linear inverses, okay? Linear functions have linear inverses. All right, let's look at what type of functions are these in example 2. Quadratic. Okay, let's see what the inverse of a quadratic function is, and I'll explain the inequality part here in a second. All right, so we switch x and y. X is equal to y squared. How do we get rid of squaring something? Take the square root. Take the square root of both sides. Okay, now typically when we take the square root, we're supposed to remember what? Anybody remember what goes in front of a square root when you take it? Plus or minus, okay, a plus or minus, but we're not going to include the plus or minus here, and I'll show you why graphically. So we've got the square root of x is equal to y, because we took the square root of y squared. That just gives us y. So we're where we need to be. But if we include the plus and the minus, so let's graph this. The square root of x and the negative square root of x. So that's the plus and minus square root of x. Is that right there a function? No. Why not? What does it fail? What's that test for a function? The vertical line test. It does not pass the vertical line test. Okay? So I've either got to consider just the positive or just the negative. Well, here's where this inequality comes into play. Okay? X is greater than 0. Does that mean positive or negative? Positive. Those are positive numbers. So the positive square root of x is going to be our inverse here. Okay? So f inverse of x is the positive square root of x. Okay, let's look at b. F of x is equal to x plus 3 squared. So we switch x and y, and we try and get y by itself. So right now, it's stuck inside a set of parentheses that are being squared. So our first step is we need to take the square roots. Now this time, our inequality is less than. So that means we need to put a negative in front of that square root. We need a negative in front of that square root because it was less than. Okay? What do we need to do now to get y by itself? Subtract 3. Okay, now, we don't put that under the square root. Okay, we cannot put anything under the square root after we take it. We can't change that right there. Okay, so our inverse, f inverse of x is equal to the negative square root of x. Notice how I make it clear that my square root ends, and then we've got the minus 3. Okay, let's do c. Okay, let's do c. G of x is equal to negative x squared minus 5 for x is greater than 0. So greater than means positive square root. Okay, I wanted to go ahead and establish that before we did the problem. All right, so we've got x is equal to negative y squared plus 5. So we're trying to get y by itself. What do we do first? Add 5. This one's a slightly different order. We need to add the 5 first. X plus 5 is equal to negative y squared. What's next? Can we take the square root yet? Is y squared completely by itself? No. We got to change all the signs, right? We got to divide by that negative 1. So we've got negative x minus 5 is equal to y squared. Then we take the square root of both sides. And we consider the positive because it said x was greater than 0. So g inverse of x is equal to the square root of negative x minus 5. So this one's different from the previous one. This one, the minus 5, is inside the square root because we did that first. Okay, we did that part first before we took the square root. The other one we subtracted after we took the square root. Now, D I put on there to point out that we cannot do this one the way that we've been doing it, okay? Because once we switch x and y, the way that it's written, we can't get y by itself, okay? Because we've got a y squared and we have a y. We cannot completely get y by itself the way that it's written. So I'm getting ready to show you here in a minute some multiple choice strategies to handle this one. But I wanted to point out that we can't find the inverse. It's not that the inverse doesn't exist. There is an inverse here, okay? But we just can't find it with the way that it's currently written, okay? I'm sorry? Multiply by 2? Well, if we multiply, that's still not going to solve the problem that we have a y squared and a y, okay? We have two different types of y's to try and get by themselves, so we can't really do it that way, okay? All right, so our original functions here, you told me were quadratics. What were the inverses? What type of functions are those? What's in them? What symbol is in there? In all the inverse functions? Square root, okay? Quadratics and square root functions are inverses of each other. Quadratics and square roots are inverses of each other. So we've got just a couple minutes left. Let me show you. Let's look at the graphs of these really quick, okay? I've already got the first one in here. Okay. So there's the inverse, there's the original. Do you kind of see how they have a similar shape? Okay, it's just kind of turned over on its side. Okay, one more property of inverse functions is that there's some symmetry here. Okay, I'm also going to graph the line y equals x, and I'm going to square my window. Okay, that makes it as wide as it is long. Okay, so if you kind of tilt your head so that you're looking at that line, okay, so that it's straight up and down, do you see how if I took the left side, I could flip it over that line and it would give me the right side of that graph? Okay, minus this part over here. Okay, but that's where the x is greater than 0 comes into play. We're ignoring the left side of this quadratic, okay? So you see that symmetry there with those two functions. I could do that with the other ones too, okay? Let's do that. Let's compare these. Let's look at B. I'll give you plenty of time to pack up. Stick with me for just a second. Let's see here. Negative square root of x, close the parentheses, minus 3. X plus 3 squared. Okay. So let's look at this one. Okay, it's a little bit harder to visualize. Okay, but on this one, we're looking at the left side of it. We're ignoring this part. But if we flip it over that line, okay, you should be able to see that symmetry between those two functions right there. That's another property of inverse functions. Okay, so